Okay. So if you recall from Wednesday, what we are doing is just looking at some situations via graphs. And we are looking at distance versus time and then velocity versus time. Okay, so as you can see on this first one, distance, so that's how far away you are from where you started. And if you recall velocity, this is just related to your speed. All right, so on velocity, as you are going away from your starting point, it is positive. If you stop, it's on the axis, and then if you're going back towards your starting point, it is negative velocity. Distance will not be negative, but velocity can be, just because that's telling you your direction. Okay, all right, so Bob is walking due east to functions class from his dorm room. Okay, so here's where he will start, and this is his dorm room. Okay, so he's walking, so here's the first thing that we're gonna graph. He's walking due east to class from his dorm room. Okay, he is walking away from his dorm room, so the distance from his dorm to wherever he's going, is that distance getting larger or smaller? Larger. As I go away, I'm 1 block from my dorm room, I'm 2, so that is growing, which means our graph is doing what? Do what? Increasing, right? Your distance is increasing, okay? So I'm gonna go ahead and say, because ultimately he's going to class, okay? So it's increasing, but then it goes on to say that when he gets halfway there, he realizes he forgot his calculator and runs back to get it. Okay, so we know we're getting halfway to class. Okay, so he is walking to class and he gets halfway there. That should be a straight line, though it doesn't look like one. Sorry about that. Okay, so at this point, what does he do? To the dorm room. So what's going on with the graph? It's decreasing, right? Now, he runs back, so I'm gonna make that slope steeper than when he was walking. Okay, so he is walking to class, so to class. And then back to room. You guys have never done this, have you? Because he forgot his calculator, okay? All right, when he gets the calculator from his room, he walks back towards class. Okay, so now he's walking again, and he's walking towards class. And then it says, when he is almost there, he sees a friend and stops. Okay, so he's walking back to class. Here's class, so I'm not there, I'm almost there, and he stops to talk for a few minutes. So here's walking back to class. So again, going to class. He stops and talks for a few minutes. What's my graph gonna do there? Horizontal, right? So the distance, he stops, but the distance away from the dorm room stays the same, but some time has to pass. So he's talking to a friend. Then he continues to class. So finishes getting to class. There's class. And stays there until class is over. Then he walks quickly back to his dorm room. So I ran out of room, but this would be going back to dorm room. So this would be an example of what it might look like. Walking away, gets halfway there, turn around, go back to the dorm, go to class, talk to a friend, walk the rest of the way, sit in class, immediately go back to the dorm. Okay, all right, so now we are going to do that with velocity. So it's going to be in relationship to my distance, right? So when he's going away from the dorm, we know then it is a positive velocity because again, here's his dorm. And then when he is going towards the dorm, we know it's negative. All right. So he starts out in this dorm on the speed and he goes up and he's walking to class. He hits this point here and he is going to go back to the dorm. So if he's going back towards his dorm, then we know it's down here in the negative. So this is going to jump down here to the negative and he goes back to get his calculator. And then he goes back to walking to class. So that's here, there he's walking to class. Okay, what's going to happen when he's talking to a friend? What's his speed going to be? 0. Here's when he's with his friend. Then he goes away from the dorm some more to finish going to class. So his speed goes back up. He gets to class. And then when he's in class, his speed is 0. And then what happens? This is going back to the dorm. Whoops, I didn't need to go that low. Sorry. Okay, so this is going to class. He went back to the dorm for his calculator. He's going back to class. Stops to talk to a friend. Walks the rest of the way to class. Is in class. So this would be to class. And then back to dorm. So there's going to be a relationship between these two. Okay. So what you need to remember is when you're walking away with velocity, it's positive. If you stop for any reason, it's 0. If you're walking back towards your starting point, it's negative. Okay. All right. So this is giving us a same type example. So we are looking at, again, distance and then velocity. All right, so now we're gonna hike. So a hiker is hiking up a mountain in Colorado. He is starting at his base camp. Okay, that's where he starts. So this is base camp. And hiking westward up the mountain. Okay, he is hiking at a slow but constant speed during most of the hike up the mountain. All right, so here's the top of the mountain, I'm gonna say. So he's walking steadily. About halfway up the mountain, so again, we're gonna have a halfway point. Okay, so he is steadily walking. So his distance is increasing and he's halfway up. So here we went slow but steady. halfway up the mountain, he stops for lunch. So then he or she stops for lunch. He also stops to enjoy the view while at the top of the mountain. Okay, so he must have gone on. So he's going to then eat lunch, get to the top, enjoy the view. On his way down the mountain, he can hike faster than he could on the way up the mountain. Okay, so what does that mean in relationship? Why does it tell me he went faster? It's gonna be steeper downward, okay? So I wanna keep reading because I don't know that I'll get all the way down. When he is near the base camp, he meets a friend who is headed up the mountain and stops to chat. Okay, so this is gonna be steeper because he can go faster. When he's near base camp, he sees a friend going up, stops to chat, and then finishes back to base camp. Up the mountain, halfway lunch. Top of the mountain, view. Faster down the hill, stop and chat, going, hey, I'm on the way down, good luck, you're on your way up. Then the rest of the way to base camp, okay? So now when we're looking then at our speed, here's our speed when we're going up the mountain. This would be our speed when we're going down. And then of course, the horizontal axis would be anywhere that we stop. So we steadily go up, constant, constant, and then we stop for lunch. Here's lunch. Then I go and I start, and my speed is till we get to the top. And then we are going to take a look at the view. And so now on the decline, we know then that directional is negative. So then we are walking down more quickly until we stop and chat with a friend. So here I'm stopping, I chat, and then I finish the rest of the way until I'm back at base camp. Right? Okay. Anybody done that assignment yet or started it or looked at it? 6.1? Is it too bad?
No.
Yeah, I didn't think it was. I meant to take a look at it and I forgot and I just don't remember. Okay, 6.2, the last section of the semester. Hard to believe. All right, rates of change for other functions. Okay, so this is what we've been doing. You can see that it talks about distance and it talks about velocity. And again, velocity is your speed. Okay, so then if we also discuss slope, we know that's the same thing as average rate of change. And we know that is the change in the distance in relationship to the change in time. So this slope right here is talking about my distance one. Okay, so let's take a look at, this should be right in the corner. So this is in relationship to distance. I want to talk about our average rates of change. Okay, so let's take a look at, I'm going to do this in pink. What is the function doing in this stem of the graph? Increasing. Okay, so let's take a look at the average rate of change when we know that the function is increasing. So I'll do that in relationship to pink. All right. Well, if you recall, if you have two ordered pairs, you can calculate the slope. So we start in the corner, which is the ordered pair 0, 0. And then I'm gonna go to the top ordered pair, which is over 2, up 120. All right, so if you recall, the average rate of change is calculated as the change in the function over the change in the variable. And the change in the function is your second numbers. So that would be 120 minus 0, and then 2 minus 0. If you go back to that section, it was y2 minus y1 over x2 minus x1. And we would get 120 over 2, which is 60 miles per 1 hour. And that makes sense. This is positive, so we know it's increasing. Okay. All right, what's going on in this section of the graph? It's constant, right? Okay, so let's take a look at when it is constant. All right, again, I'm going to use 2 ordered pairs. We have 2 120. And then we have what? 3 120? Now, what makes sense in this? If I'm here, what makes sense as far as how many miles per hour I'm going? What number represents not moving? 0. All right, let's see if that's what happens. So the average rate of change would be 120 minus 120, 3 minus 2, and it would give me, I'm going 0 miles per 1 hour. That makes sense. All right, and then here, the last bit of my distance graph is doing what? So what should happen with the average rate of change when we calculate it? If it's decreasing, what would that average rate of change be doing? It should be negative. Let's see if that's what happens. Okay, so we have 3 120. And we have 5 0. So the average rate of change will be 0 minus 120, 5 minus 3. That's going to be negative 120 over 2, which is going to be negative 60 miles per 1 hour. And that's because it's decreasing. So from what we've done in the past, that all makes sense. Okay. All right. So then now we are including velocity. So this reads the change in speed over the change in time, because we've been talking about how velocity is speed. Okay. So we're going to learn some new terminology as far as how it's written. So instead of using these little boxes, which mean the change in speed over the change in time, we use a special notation for velocity that is ds over dt. ds over dt. Okay, that's new. Let's read on and see what it tells us. For a function called f of x, the rate of change in f with respect to x would read df dx, where f is your function, x is your variable. So it is the rate of change for f with respect to x. So this is actually some terminology that we use in calculus. So some of you, maybe none of you, okay? There is a class called Business Calculus, and I actually teach it in the spring. And if you've had STEM or functions, you can take this class. So this is some groundwork that if you end up taking business calculus, that you've actually seen a little bit, okay? So in calculus, what we call this is the derivative of f with respect to x. Okay, all right, so let's tear all that away and go, okay, yeah, but what do I need for this class? Okay, here's your important information down here. df dx tells us the change in f when x is increased by 1. So if we're relating that to this up here, it would be your change in speed when x or when t is increased by 1. Typically, so what we've been talking about so far, that would be 1 hour, right? Okay, so if the function is increasing, and we've already talked about this. So if the function is increasing, so right here, when the function is increasing, what is your speed? Positive or negative? Positive. It's up here, it's positive. That's what this bullet point is telling. If the function is decreasing, your speed is where? Negative. It doesn't mean that you're going to negative speed. That's just the direction that you're going. If your function is constant, then my speed is at 0. Okay, so we've kind of already talked about this. We just did not use the df dx here, but we've actually talked about this. Now, this last bullet point says if the function has a maximum or a minimum, then the df dx or the velocity is 0 at that point. So we've talked about if we have a function like this, the top of the hill would be your max. The bottom of the hill would be your minimum. So what this means is you would have a positive velocity. You hit this peak, it is briefly constant at 0. And then you would decrease and it would be negative, and then you would briefly pause, it would be 0, and then it would increase again. So that's what that last bullet point is talking about, okay? All right. All right, so here's what we've got. We've got a bird. He flies up out of a tree. So let h be the height of the bird above ground level as a function. Okay, so we can define our function h, which is the height of the bird. And t time in minutes. So this would be per 1 minute then. So variable would be t, which is minutes. Now, a lot of these questions are going to be more conceptual, not, hey, here's a formula, plug it in and get a numerical answer, okay? So we're gonna be conceptually thinking, what is our bird doing? So it makes sense that if he is flying upward, what type of velocity would he have? It's increasing, right? If the bird's flying upward. If the bird's not moving, sitting at the top of a wire, flew up to the top of a building, changes direction, what's his velocity? 0. And then if he is flying downward, it would be decreasing. So it's a conceptual thing, okay? So we start out with A, explain in practical terms the meaning of dH with respect to dt. Okay, well, let's go back to what we just talked about. So if I want to think through this, h represents what? Height. So this would be the change in height per one, what? Minute in this case. Oops, can't spell minute today. Okay, so if I think of that, then all I have to do is rewrite this in sentence form if it says to explain. So I would say the change in height of a bird, I'm gonna let them know we're talking about a bird, per 1 minute. That's all it's asking for there. Okay, so if DHDT, so if the change in the height of the bird per 1 minute, is that going to be positive or negative when the bird is flying up? So the bird is flying up. So will that change in height per minute be a positive or a negative? Positive. Okay, it will be positive. So if I were to write that, I would say the bird has positive velocity because it is increasing. That's what upward would mean. So flying up represents increasing. So we would have positive. Okay. For just a moment, the change in the height per minute is 0. So our bird is flying up, then just for a moment it's 0. What do you think is going on then? If it's just for a moment 0, what do you think the bird's then gonna do? Do what?
Change direction.
Yeah. So now, if we're flying up, what has the bird reached right here? What do we call that? The top of the hill. What? The max. So the bird reached a maximum height and then changed direction. Now, the next question is saying, hey, that change in height per minute is still 0, but now it's for a while. So the bird's flown up. Now, instead of just for a moment and then changing direction, the bird's gonna hang out there for a while. What do you think that maybe is going on with the bird in the air? Do what? Resting. Probably stopped at the top of a wire, stopped at the top of a building. So we could say the bird stopped to rest on top of a building or wire. Or scoping out, watching what it's gonna nosedive and go get for lunch. All right, as the bird comes back down to land, is that change in height positive or negative? And that's because what's going on? It's decreasing. So the bird's height is negative because he is decreasing. Okay, So that's all conceptual. Obviously, we didn't do any calculations. Okay. Same thing here. Okay. You are considering buying 3 stocks. Okay, so they're gonna call those stocks P1. T represents time, so it's how much profit over time. Or if you're buying stocks, it wouldn't necessarily be profit, but anyway, they're calling it P. Okay, all right, and then a second stock would be P2 over time and P3 over time. So we have some investments and we'll get periodically, they'll send us in the mail statements and y'all literally, it can, you know, now it never thankfully has done this, but we'll get a graph and it'll go up and then it'll stay the same and then it might go up a little bit, stay the same and then go down. So all of this in money world is what we're talking about here. Okay, so it's going to give us some information. You know that the change in your money over time is a large positive number. So what is my money doing? So if I'm talking about this one, what is my money doing here? Increasing, decreasing, staying the same? Increasing. Okay, so if I just looked at a graph for this one, we would know that my money is increasing. Then the second stock, so the change in my money over time is near 0. Well, what type of line would represent that? A horizontal, because my money is remaining what? Constant. Meaning, boo, I'm not making money, but yay, I'm not losing money either, right? So if you want to look at half empty or half full. And then lastly, the third stock, the change in my money over time is a large negative number. So that tells me my money is doing what? Decreasing. Decreasing. That's a big fat boo. All right, so then it goes on to say, which stock will you buy? Which one would you want to buy? Yeah. For sure. All right, we're trucking right along. All right, water is leaking out of a tank. Okay, I'm going to attempt to draw a tank. All right, so there's a tank. That's not too bad. And water is leaking out. Okay, so we've got a water leak. This is my water. All right, the amount of water in the tank T minutes after it springs a leak is given by, okay, so here's functional notation. So functional notation, you can tell me, or I would hope you could tell me the letter that represents the function. What is it? W. And what does that represent? Water in gallons. So this is your water in the tank, and they told us that we're talking about gallons. All right, so what is my variable then? T, which is minutes. All right, so we're going to be talking about the change in the water per 1 minute. That's what this represents, which is what it's going to ask me to write right here, and I just said it, right? So we know dW means the change in water per, in this case, would be 1 what? minute, okay? So again, you don't have to write this in the explain, I just, for those that it's helpful to see both. So the change in water per 1 minute. As water leaks out of the tank, is that change in water per 1 minute positive or negative?
Negative.
Okay, because the water level is doing what? Decreasing, yes. So negative because the water level is decreasing. All right, for the first 10 minutes, the water is leaking from the tank at a rate of 5 gallons per 1 minute. So the change in water per 1 minute, whoops, I'll do DT, is 5 gallons per 1 minute. Isn't that how we would write that? So it says, what do you conclude about the nature of the function W during this period? It just is asking you what is the water level doing? And it's kind of a, you go, well, didn't we just answer that in the prior one? Yes, because the amount of water is doing what?
Decreasing.
Yeah, so the amount of water is decreasing. So it's very similar to B. But again, I can't really do anything with it as far as numerically unless I had the actual function. All right. After about 10 minutes, the hole in the tank suddenly gets larger and water begins to leak out at 12 gallons per minute. Okay, so it was 5 gallons, now it's 12 gallons per 1 minute. So it started out leaking this, and now it is leaking this. So again, the water level is still decreasing, but at what type of a rate in comparison? A faster, right? So this would be steeper. So make a graph of the water versus time. And then, so this is the level of water versus time, and then the velocity of that. Okay, so let's take a look at that. Let's just first do W, which is your water level. Per T, which is minutes. Now, am I gonna start here in the corner? If I start in the corner, how much water would that represent?
0.
0. So I've got water in the tank, right? So I'm gonna start here. So I don't know how much water, but up here is however much water that you have. Okay, so it starts leaking at 5 gallons per minute. So we've got a slow leak of 5 gallons per 1 minute. And then it hits a point, that hole becomes larger. So I'm still decreasing, but what's gonna change? It's gonna be steeper. So now it's going out faster until it empties out. So this would be your 12 gallons per 1 minute. So we'll do the slow in the green and the fast I'll do in the orange. So then when we do our velocity, right? So this is our velocity, which we are now showing that as the change in the water level per the change in time. Our time is still minutes. Here's 0. Up here is positive, and down here is negative. So where would, because we're not going away from a dorm and towards a dorm, so where do you think when this is decreasing though, where will it be on our graph? Positive or negative? Negative, right? Decreasing is always negative. The only difference is it was a slow decrease and then a fast decrease. So I'll do this as -5. So we started with when minutes, all of a sudden it started leaking. And it was leaking, and then all of a sudden it started leaking more until we had no water in the tank. So this would represent your 5 gallons per 1 minute leak. And then I would just go further down to represent your 12 gallons per 1 minute leak. Okay. Okay, we are gonna stop there. Now, we're finishing 6-2. It's gonna be due Monday, all right? So on Monday, we're reviewing for the test, so I don't wanna spend a lot of time on this last extra practice. So I will have this up at the beginning of class before we start the review on Monday, but I highly recommend between now and Monday that you try to work it so it's a comparison thing, not hastily writing it down because I was lazy and didn't do it. Was that a little passive aggressive on my thoughts on that? Okay, so